Today we'll be looking at our anchor line of meters. This is our basic meter. This is our higher end meter with an amp clamp. Today we'll be testing DC volts, AC volts, current and resistance. We'll start with DC voltage. I'm going to take the amp clamp meter, turn it to the V with the wavy line. If you look at here, you'll see that it says AC. Since we're going to be doing DC, 1, 2, it should say DC on top of the meter. Now to begin the testing, we're going to take the black lead and take it to the COM or negative. We're going to take the red lead to the positive, and we should see 12.6 volts on the meter. Now we're going to go to the next step. We're going to check out the fuse block. We're going to verify that power is getting to the fuse block. Since the wire is running over to the fuse block, we can check here and see that we are getting 12.6 volts to the fuse block. Our next test is on the other side of the fuse box. We'll check here and say that yes, the fuse is good. We have 12 volts going through the fuse. If the fuse was bad or removed, we would see 0 volts on the output of the fuse block. Our next test is following it over to the switch. To find out if the switch is getting power, we can start at the tab on the switch, and we're still touching the negative bus bar, and you can see on the meter we are at 12.6 volts. At this point, we know that power is flowing from the positive bus bar to this side of the switch. Now, if we measure the other side, or the output of the switch, or load side of the switch, we'll see we have 0 volts. That is because the switch is off. If we turn on the switch, you can see that the power is going to the light, but we can also measure that we have 12.6 volts on the output of the switch. And this is how we test a DC volt circuit with a multimeter. Now we'll be using our anchor amp clamp meter to measure AC amps. First thing we want to do is turn the meter to AC amps from off, which is A with the wavy line. We are then going to clamp the meter around the hot wire and apply the load. In this case, it'll be a lamp. In this case, we can see that this lamp is drawing 0.22 amps. Now we're going to remove the clamp meter and apply it around all the wires. In this case, because the power going in and the power going out on the neutral, it does not show any amps. This is why we clamp around just one of the wires on the outlet. Now we'll be working on an anchor amp clamp meter and how to measure DC amps through a circuit. First, we have power connected to the circuit. We'll turn power on to our load, which is our LED light. We'll be setting the meter to A with a line and 3 dashes underneath. That's for DC amps. Next, we'll take the clamp meter. We'll clamp it around the negative wire, or wires in this case. And now we should see 1.8 amps going through the circuit. This is how we measure amps going through a DC circuit using the anchor amp clamp meter. Now we'll be testing an AC voltage circuit with our anchor amp clamp meter. So now we're going to set the meter to AC volts. It should see AC volts on the side of the meter. If you don't, you can use the select button to select AC volts. Next, what we will do, we'll take the red lead into the hot terminal on the outlet. We'll take the black lead and put it into the neutral, and we should see 120 volts. If we take the black lead and put it into the ground, we should also see 120 volts. The last test we do is we take the red lead and put it into the neutral, take the black lead and go to the ground, and we should see 0 volts. This is how you test an AC circuit with the anchor amp clamp meter. Now we'll be doing continuity. We'll be setting the meter to the horseshoe, or what they call the ohm setting. There's also a sound setting on it. So what we're going to be looking at is continuity between 2 points, or resistance. And so basically we're going to start at this point A, go to point B. As you can see on the multimeter, we should see 0.0 or very close to 0. That shows that the power has gone through the wire and is actually at that point. And that means the wire is a good wire. To look at it differently, here's a good wire. If we touch point here and point here, You can see again that there is no resistance because it is a good wire. Now this wire, as you can see, has a cut in it. Basically, was damaged in the field, got rubbed, or however. From here to here, we have OL, or infinite resistance, meaning it's not making contact at all. We have the same problem here, as this wire has been burned through. If we connect here to here, again, we have infinite resistance, as there is no longer strands of copper touching both set points. So we should see OL on the meter. The last wire we have is another common failure, is crimp that hasn't been done right. In this case, even though the wire looks perfectly intact, if we measure the resistance, you'll see that it is OL, as one side of the wire is not crimped properly. This is how you use an Anker multimeter to do a continuity or resistance check.